What does it mean to solve a triangle? Solve a triangle. Well, that means a triangle has 6 parts, 3 sides, 3 angles. And right now in this problem, we only know 2 of the parts, or actually 3 of the parts. We know 2 of the sides, and we know 1 of the angles. Angle C is a right angle. So when I say solve the triangle, what I need you to do is find the third missing side, and then find the measures of angle A and angle B. So how are we going to do that? Well, for part of it, we're going to use the Pythagorean Theorem, and for the other questions, we're going to use trigonometry. Let's start with the Pythagorean Theorem. If you have a right triangle, and you know 2 of the sides, you can find the third side using Pythagorean Theorem. And the Pythagorean Theorem, as a reminder, says that in a right triangle, the sum of the squares of the legs equals the square of the hypotenuse. And what happens is usually it's labeled as one of the legs is A, the other leg is B, and the hypotenuse is C, and you get A squared plus B squared equals C squared. All right, so there's the Pythagorean Theorem. So let's use that for this problem. We've got B squared plus 27 squared equals 45 squared. And so we're probably going to need a calculator to figure this out. But whatever I get for 27 squared, I'm going to subtract that to the other side. So whatever 45 squared is minus whatever 27 squared is, that'll be B squared. And so then to find B, we're going to take the square root of both sides. And the square root of B squared is the absolute value of B, but in this case we know B is positive because it's the side of a triangle. And so now I'm going to grab my calculator and I'm going to put all of that in one entry, square root 45 squared minus 27 squared. And we get an exact answer this time. You don't always get an exact answer, but the answer is 36. So we found the third missing side. Okay, now let's work on the angles. Now we can start with either angle we'd like. Let's start with angle A. Because this is a right triangle, we can use right triangle trigonometry using sine or cosine or tangent. Now we did just figure out that B was 36, but let's use the 27 and the 45 because in case we made a mistake on B, then we're going to make another mistake to find angle A. So I'm going to stick with the 45 and the 27. The first thing I want to do is label my triangle for angle A. 45 is your hypotenuse. Side B is the opposite leg, which we're not going to use. And the 27 is the adjacent leg. So which trig function uses the adjacent and the hypotenuse? Well, if you remember, SOHCAHTOA. The sine uses opposite and hypotenuse. The cosine uses adjacent and hypotenuse. Oh, that's what we want to use. And by the way, the tangent is opposite and adjacent. So the cosine is the function we're going to want to use. So I'm going to write cosine of angle A is equal to the adjacent, which is 27, divided by the hypotenuse, which is 45. Now, the cosine of angle A is 27 over 45. We need to find just angle A. So as we've talked about, to get rid of the cosine or to undo the cosine function, we're going to do the inverse cosine function on the other side, on your fraction, 27 over 45. And so we're going to need a calculator. And we're going to do the inverse cosine of 27 divided by 45. Let's make sure we're in degree mode. Right there, degree mode, good. So I'm going to press second cosine, 27 divided by 45. And we get a little more than 53 degrees. So we'll round it to 2 decimals. We'll go to the nearest hundredth, 53.13 degrees. 53.13 degrees. There was no specifications on how far we should go for rounding, so I'm making the call. 53.13 degrees. All right, now we need to find angle B. We can do the same procedure to find angle B, except now this would be adjacent, this would be opposite. The hypotenuse is still the same. And we could say the sine of angle B is opposite over hypotenuse. But we don't need to do all that work. We know that all three angles in a triangle add up to 180 degrees. Minus the 90 that we have for the right angle means the other two always add up to 90 degrees. So all I need to do is subtract 53.13 from 90, and that'll be what? Let's try subtracting correctly. That'll be 36.87, I believe. And so there's your angle B, 36.87 degrees. And now we have solved the triangle. All right, so if you understand the idea of what you need to do to solve the triangle, let's go and look at the different types of equations you could wind up with when you're doing trigonometry. Make an arrow here. All three of these equations kind of look the same, except what's different? Look where the x is. Here the x is inside the sine function. Here the x is in the numerator of your fraction. And here the x is in the denominator of your fraction. So the approach to solving these equations is going to be a little bit different for each one. So let's start with the first one. The sine of angle x is 4/5. Now you have to remember, the sine is a function. If I had given you, let's say, the square root of x equals 4/5, and I said solve for x, what would you do? Well, you need to undo the square root, and to undo the square root, we would square both sides, and then the square and the square root cancel, and we're left with just x. Same idea here for the sine function, and you'll learn more about this in the next course, but you're going to want to actually take the inverse sine function, which will cancel the sine function. And so we're going to do the inverse sine of both sides. But usually people don't write inverse sine of x. But you should understand why we're doing this. So x is equal to the inverse sine of 4/5. Normally, the sine function takes an angle and then returns to you a ratio in the form of usually a decimal in the calculator, or a fraction if you're looking at a picture. The inverse sine function takes a ratio and returns to you an angle. And that's what we're looking for, is an angle. So when you have the sine or the cosine or the tangent of x equals, you're going to do the inverse of that function on the calculator to see what you got. So we're going to do the inverse sine, second sine, 4 divided by 5. And there's 53.13. That looks familiar. Oh, that must have been a similar triangle to the one in the opener. So x is approximately 53.13 degrees. So that's how we solve it if the variable is inside the trig function. Okay, what about here? Now, here's what you have to think of. Sine of 37, that's just going to give you a number. If I had given you the equation 5 equals x over 17, how would you do that? Well, we need to isolate the variable, get x by itself. We have to undo divide by 17, which would mean we would multiply both sides by 17. Those would cancel, reduce down to 1, and then we would just get x equals whatever, 85. So the same idea here, because the sine, let me show you in the calculator, the sine of 37 degrees is going to give you a number, a decimal, 0.601. So that's just a number that we're looking at on the left side of this equation. All right, so to undo divide by 17, we're going to multiply both sides by 17, and that's going to give us what x equals. And I should write approximate because we're going to have to round it to some extent here. So I'm going to grab the calculator and do 17 times the sine of 37 degrees. And I get 10, we'll go hundredths, 10.23. So 10.23. Okay, the last equation, kind of similar to the second one, except now x is in the denominator. So how are we going to handle this? Well, once again, I want you to remember sine of 52 is just a number. If I gave you 3 equals 22 over x, how would you solve that? Well, we could multiply both sides by x. So now x isn't in the denominator anymore. And then x times 3 is 22. We would divide both sides by 3. And then that's how we could get x by itself. Another way of thinking of it, since we've done proportions before, you could put this over 1 and cross multiply, and you get x times sine of 52 is equal to 22 times 1, which is just 22. So that's another way to think about it. Back up. So whichever way you want to think of, you're still doing the same calculation. So x times sine of 52 is equal to 22. And then we need to divide both sides by sine of 52. And the signs here are reduced down to 1. And so we're going to get x is approximately equal to, and grab our calculator, and we'll do 22 divided by sine of 52. 27.918, so the 8 is going to make us bump up the 1 to a 2. So 27.92. 27.92. And there's your answer. Okay. What you might notice, and after doing enough of these, you'll say, oh, it's just a shortcut. When you look at this original equation, what did we wind up doing? We wound up moving the x over here and putting the sine of 52 under here. So we just basically switched these positions. And we got 22 divided by sine of 52. All right, so the 3 different things. You get your variable inside a trig function. You have to do the inverse trig function of the other side. If x is in the numerator of your fraction, just multiply the denominator to the other side and get your decimal approximation. If x is in the denominator, move it to the other side, divide by the trig function, and then use your calculator to get another decimal approximation. The assignment is worksheet 4. And I just want to point out a couple things as you work through this. On the first page, it says find the indicated side. So we can't use the Pythagorean Theorem on this type of a problem. I think this is supposed to be the letter I. Doesn't look like an I. So we only have one side. We don't have this side. So we can't do the Pythagorean Theorem to get the third side because we only have one side. But we do have an angle. So what we have to do is say, okay, for this angle in a right triangle, let's label our sides. This is hypotenuse. This is adjacent. This is opposite. We're going to be using the adjacent and the hypotenuse. So which one was that? SOHCAHTOA. Probably want to have this written at the top of your paper. Which one uses adjacent and hypotenuse? That's the cosine. So you're going to say cosine of 35 equals 8 over I. And we just got through talking about how you solve that. We're going to put the I over here and move the cosine underneath the 8. Grab the calculator, punch that in, and you'll get your approximation. And that'll be blah, 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 whatever for I. Okay, so that's how you do this side. Same idea for all of these. You decide if you use sine, cosine, or tangent. And then for the other side, find the measure of the angle. And here, they're giving you all 3 sides. We want to find the measure of angle U for number 1. So let's label our sides, hypotenuse, opposite, adjacent. Now since they're giving us all 3 sides, we really can use any one of the trig functions we want. So you pick, I don't know, let's do tangent. The tangent of angle U is equal to opposite over adjacent. Tangent is opposite over adjacent. So 18 over 24. How did we solve these equations? Our variable is inside the trig function. So angle U, we have to do the inverse tangent of the other side. And then you grab your calculator and punch in inverse tangent of 18 over 24 and get your answer.